Hi guys, so today we're going to talk about vectors. It's kind of an introduction to vectors. If you've taken AP Physics before, some of these things may be familiar to you. So a vector is a directed line segment. You can see that here. It's a quantity that has both magnitude, which is the length. Magnitude is just the length, and direction. So you can see here, we see this directed line segment PQ. So P is the initial point, or the tail. Q is the terminal point, or the tip. Vectors are denoted with that arrow symbol over the top. All right, so given a vector v with points x1, y1, and x2, y2, you can find the magnitude or the length by using distance formula. And remember, with distance formula, it doesn't matter what order, you just have to keep it consistent. So we'll do one example here, but distance formula should be familiar to you. So if I was going to find the magnitude of number 1, I would do the square root. The order in this case, obviously because you're finding the magnitude, it doesn't matter, but just A is the initial, B is the terminal. So I'm going to do it as -7 minus 8 squared plus -2 minus -4 squared. That gives us, when we type it in our calculator, the square root of 229, which doesn't simplify. If it does break down, make sure you break it down. All right, zero vector is a vector of 0 magnitude and direction. All components would be 0. All right, so that brings us to just a couple of these definitions. There's parallel vectors, equivalent vectors, and opposite vectors. Kind of means exactly what you think they mean. Equivalent would be the exact same. Parallel is the same or opposite direction, but not necessarily the same magnitude. And opposite vectors, same magnitude, same length, but opposite direction. So let's just look at a couple of these here. A and E. Okay, so notice those have the exact same length, but they're going in opposite directions. So those are going to be opposite vectors. Okay. I and F. So if we look at I and F, those are going to be parallel because they're going in they're the same magnitude and the same direction. Actually, that one should actually be equivalent because they have the same magnitude and the same direction. Sorry about that. Okay. And let's look at one more, D and E. Now notice those are the same direction, but not the same magnitude. So that's why those are parallel. So technically number 6 is parallel, but to be more specific, we say that they're equivalent. Okay. So to prove they're equivalent, same magnitude, same direction, meaning same magnitude, same length, we can do that with the distance formula, and same direction, do that with the slope formula. So if I'm looking at AB right here, to find the length, that would be -2 minus -6 squared and 3 minus -7 squared. That gives me 116. To find the length of CD, that would be 6 minus 2 squared plus 0 minus -10 squared. Type that in your calculator. That also gives you 116. So those definitely have the same magnitude. To find the direction, that's just the slope. So 3 minus -7 over -2 minus -6 gives me 5/2. It actually gives me 10 fourths, but that simplifies to 5/2. That's for AB. And then for CD, 0 minus -10 over 6 minus 2, that's also 10 fourths, which simplifies to 5/2. So these are equivalent because they have the same magnitude and the same direction. All right, standard position is when the initial point of the vector is at the origin And so a lot of times it's not automatically like that, but we can rewrite it in terms so that we can have the initial point at the origin. So we write the component form with, it kind of looks like these V brackets, A comma B. Now, because if you look at like right here, if this is A and this is B, when it's at the origin, you can find the magnitude. Think about it kind of like Pythagorean theorem. So the square root of A squared plus B squared, because that would give you the length of this, because that would kind of be your hypotenuse of the triangle. For the direction angle, which is this angle theta here, you could do it a bunch of different ways, but with just the coordinates A and B, we know that tangent of theta is opposite over adjacent. So in that case, that would be B over A. So then to find actual theta, remember you do the inverse of B over A, because that's opposite over adjacent. So let's do a couple examples here. Let's start with 724. First, if I'm finding the magnitude, 7 squared plus 24 squared. Because remember, that means that I have the point, initial point 0, 0, and then the point 724. So you'll get the same thing either way. When you get that, you'd get the square root of 625, which is 25. So that is the magnitude. Finally, the direction angle. So direction angle is tangent inverse of 24 over 7. Make sure that your calculator is in degree mode for this. Okay, and we'll also have to take into account what quadrant we're in. 724 would be in the first quadrant because both of them are positive. I'm going to go change mine into degree mode. And then do tangent inverse 24 over 7. And that gives me 73.74 degrees. Because I'm in the first quadrant, that's my final answer, between 0 and 90. All right, let's look at one that's not in the first quadrant. Let's look at number 2. Okay, on number 2, I'm in the third quadrant because negative, negative. Okay, now to find the magnitude, it's going to be the same thing. Negative 3 squared plus negative 1 squared gives me the square root of 10. That's my magnitude. To find the direction angle, I'm going to start just like normal, tangent inverse negative 1 over negative 3, and type that in my calculator. That gives me 18.435 degrees. Now, a little bit of a problem. Remember, tangent inverse has restrictions in the first and the fourth quadrant. So your calculator is only going to give you something in the first or the fourth quadrant. We know 18 degrees is in the first quadrant, but that's not what I want. I know that my vector is in the third quadrant because those are both negative. So how am I going to get this angle over here? Well, it's exactly halfway around the circle, so I just need to add 180. So sometimes you'll have to do a little bit of problem solving to figure out what that angle actually is. So this one is 198.435 degrees, and that would be your final answer. Okay. All right, let's do one more, and then we'll practice kind of putting it all together. Actually, let's go to the next page. We'll do a couple where we put it all together. All right, so any vector with an initial point x1, y1, x2, y2 can be written in component form by doing x2 minus x1, y2 minus y1. Kind of picture, you can see it in this picture here, but you're taking that vector and you're moving it so that its initial point is at the origin. All right, so we're going to do 7, 9, 10, and 13. Okay, so for number 7, if I was going to write this in component form, this is initial, this is terminal, so 6 minus 3 is 3, and 3 minus 5 is a negative 2. That's the component form. All right, let's look at number 9. This is where we have to find all the things. So we have to first find component form, then magnitude, then direction angle. So first for component form, mn. So I'm first going to subtract my x's. I get 2. And then subtract my y's. 1 minus negative 9 gives me 10. That's my component form. All right, then for the magnitude, remember you can just do square root of a squared plus b squared once you get it in this form. If you wanted to do it with your 2 points, you'd have to use distance formula. All right, Now that gives me the square root of 104, but that does simplify because I can divide that by 4. So that's square root of 4 times 26. So that's 2 square root 26. All right, direction angle, tangent inverse. Give me 1 second. Tangent inverse of 10 over 2. So I can go tangent inverse 10 over 2, or you could just type in 5 there, is 78.69 degrees. And because that's in the first quadrant, my vector's in the first quadrant, so we're good. That's my final answer. All right, let's look at number 10. Okay. All right, so for number 10, x minus x, y minus y. So negative 4 minus 9 is negative 13. Negative 1 minus negative 3 is 2. Find the magnitude square root of negative 13 squared plus 2 squared. So that's 169 plus 4. So that's square root of 173. That does not simplify. Then the direction angle, tangent inverse of 2 over negative 13. I'm going to type that in my calculator. That gives me negative 0.002. Okay. So then when I go, if you think about that is, make sure that doesn't look right. Let's see. Let's make sure we're in degree mode. Oh, that's because I did tangent, not tangent inverse. Okay. Tangent inverse of 2 over negative 13, sorry about that, is negative 8.746. All right, so negative 13, 2 is in quadrant number 2 because x is negative and y is positive. It just gave me negative 8 point something, right? Now, to get to the other side, I need to add 180 to that. And I get 171.254 degrees. Now, that does make sense because that is in quadrant 2 between 90 and 180, and my vector's in quadrant 2. So 171.254 degrees would be your final answer for the direction angle. All right, lastly, determining if they're equivalent vectors. You can also do that using component forms, okay? So determining if their component form is the same. So AB, if we did negative 7 minus negative 3, that would give me negative 4. Negative 2 minus 6 is negative 8. Then for CD, negative 1 minus 3 is negative 4. Negative 9 minus negative 1 is negative 8. So yes, those are equivalent. So remember, vectors are directed line segments. They have length and they have direction, okay? To determine the length, it's just distance formula. Or once you get it in component form where the initial point's at the origin, you can just do Pythagorean theorem, square root of a squared plus b squared to give you v squared and then take the square root. To find the direction angle of one with the initial point at the origin, it's just tangent inverse of b over a, because remember this is opposite and this is adjacent. Okay. To determine if something's equivalent, you can use distance and slope formulas, or if you're comparing two component forms, if those are equal, then the vectors are equivalent. Okay, so that kind of gives you a little bit of an introduction into vectors, and we will continue to work on this tomorrow.